Circuit breaker, what is it and how does it work? Circuit breaker. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current, typically resulting from an overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. Unlike a fuse, which operates once and then must be replaced, a circuit breaker can be reset, either manually or automatically, to resume normal operation. Construction of circuit breaker, M.c.b. An M.c.b embodies complete enclosure in a molded insulating material. This provides mechanically strong and insulated housing. Remaining parts of M.c.b are: incoming terminal. Incoming terminal is made up of electrolytic copper or silver alloy, and this is where the incoming phase is fixed. Next part is arc chute. Arc chute is a stack of mutually insulated parallel metal plates which divide and cool the arc. Bimetallic strip is part of thermal tripping arrangement, around which a heater coil is wound to create heat depending on the flow of current. Magnetic coil is part of thermal tripping arrangement, where in case of short circuit or heavy overloads, strong magnetic field is produced in the coils. Copper braid connects the moving element with the static element. On-off switch is operator with which we manually interrupt or turn on the electric circuit. In outgoing terminal we connect outgoing phase from circuit breaker. Working principle of circuit breaker. The most important thing that circuit breaker is doing is to safely and reliably switches off electrical circuit during abnormal conditions of the network, that means overload condition as well as faulty condition. Under normal working conditions, circuit breaker work when we switch operator manually from position off to position on. Electric current carrying path shown in animation. First incoming terminal, then contact point of moving in fixed contacts, then magnetic coil, then bimetallic strip, then outgoing terminal. All are arranged in series. Under overload condition, the current through the bimetallic strip causes to raise of the temperature of it. The heat generated within the bimetallic is enough to cause deflection due to thermal expansion of metals. This deflection further releases the trip latch and contacts get separated. The visual indication of this trip can be observed by automatic movement of the operator to off position. In tripping operations, an arc is formed when the contacts start separating. This arc is then forced into arc chute plates, where arc is formed into a series of arcs and at the same time energy extracted and cools it. Closer look how tripping mechanism works. Types of miniature circuit breakers. Miniature circuit breakers are classified into three major types according to their instantaneous tripping currents. They are Type B, Type C, Type D. Type B of miniature circuit breaker. This type of will trip instantly at a rate of 3 to 5 times its rated current. These are normally used for resistive or small inductive loads where switching surges are very small. Therefore, these are suitable for residential or light commercial installations. Type C of miniature circuit breaker. This type of will trip instantly at a rate of 5 to 10 times its rated current. These are normally used for high inductive loads, where switching surges are high, such as small motors and fluorescent lighting. In such cases, type C are preferred to handle higher value of short-circuit currents. Therefore, these are suitable for highly inductive commercial and industrial installations. Type D of miniature circuit breaker. This type of will trip instantly at a rate of 10 to 25 times its rated current. These are normally used for very high inductive loads, where high inrush current are very frequent. These are suitable for specific industrial and commercial applications. The common examples of such applications include X-ray machines, UPS systems, industrial welding equipment, large winding motors, etc.